Good morning, everyone. So, as we know from our previous classes, that rivers are one of the important agents found within the nature, which can erode as well as transport the weathered materials from their source to a long distance and deposited them in a basin. Now, if we consider the transportation of river or streams, second one is by saltation and third one is by solution, and the fourth one is obviously the suspension. Now, processes or four mechanisms, you can see that these three, the bed load, saltation and suspension, these three together known as solid load, these three, because they are moving along with the water without changing much their chemical composition. So the physical uh, characteristics of the weathered particle that remains almost same within the water body, whereas when a weathered material is goes into solution by some chemical weathering processes, that means it is dissolved completely and lose its chemical properties, lose its physical entity within the solvent, within the water, then it completely lost its identity and it's disseminated within the water as some cations and anions. So this load is known as solution load. So if I try to divide the entire carried material by a river, it will be of two types. One is the solid load, another is the solution load. Among solid load, there are three types. First one is the bed load, where a sedimentary grain moves in contact with the bottom surface, and in this type the sediment grain remains always in contact with the bottom surface. Now bed load can be of two types, one is rolling, another is sliding. In rolling, alternate surfaces of the sediment grain came alternately in contact with the bottom surface, whereas in sliding, always one surface of the sedimentary grain keeps contact with the bottom surface. In case of saltation, the sedimentary grains periodically came in contact with the bottom surface. That means the grains move through some jumping processes, and through this jumping, with some interval of time, they came in contact with the surface and again they goes back in the water, after some time again came in contact. So this type of periodical contact with the surface and again goes back to the water is known as saltation. And the third process, which is known as suspension, here the grains are so fine, so light, that they never came in contact with the bottom surface. They always move along with the flowing water in suspension. So these are the four ways by which a river can transport its load, transport the weathered sediments. Now, from the mechanism, you can see that depending on the weight, depending on the size of the material, the transportation mechanism is dependent. So, the among the solid load, the bed load particles, they are the most coarser particles, and obviously, therefore, they are the most heaviest particles. That is why the river water is not able to lift them from the bottom surface of the river. so they move as the bed load. In case of saltation, the grains are relatively finer and thereby they move through jumping and came in contact alternately through the surface. And in case of suspension, the grains are very fine. They are almost fine sand to seal to clay size particles. So thereby you can get an idea that from the source rock, when a river weathered and erode all these particles, we came to know that from the source to river mouth, when river meets with a permanent water body, gradually the energy condition of river decreases. So with its changing energy condition throughout the river course, in different stages of the river, we can see different sizes of grains along the river channel path or at the side of the river channel path, because with changing energy condition the rivers may not able to carry different size particles. So at higher energy condition, river can carry all these size particles. Whenever the energy condition from that higher energy condition was dropped a little bit, the river is not able to carry these large size particles, so they drop them to the surface. That means they deposited them. Similarly, at this condition, these grains are carried, that is the pebbles or coarse sand grains, and along with the silt and clay grains. Again, when energy condition drops, these pebbles and coarse sand grains are deposited. So likewise, we get a general sorting of grains if we look at the entire flow path, entire channel length of the river. So from its source to mouth, gradually the grain sizes decreases. Sorry. Look at the fluvial deposition processes. The deposition of sediments from the river water happened mainly due to two processes. The first one is loss in transporting power. That means the energy condition of the river is dropped, and thereby the river is not able to carry the load further. And the second one is the excessive load is produced to the river water. So coming to the first one, now loss in energy of river water may be happen due to decrease in velocity. If the flow velocity of river water is decreased, that means the energy condition of the river water at that place becomes low. So this lower of energy condition happens, or lowering in velocity happens due to decrease in slope or decrease in channel gradient, increased in spread of stream waters. If the river water spread far from the restricted channel, that means if the same volume of water is flowing through a narrow channel by the side, at the same time the same volume of water is flowing through a much wider area, then obviously where the channel width is narrow, there the speed or the velocity is much higher, whereas the river where flows through a much wider area, due to the much wider superficial uh, flowage, superficial coverage, the river comes into contact more with the surface area. That means it face more resistance to flow, so thereby velocity decreases. So more and more surface area covered by a reef, more and more spreading of river water occurs, the river velocity will be decreased. Decrease in water volume. If the supply of water through the river channel decreased, it is most commonly found in the seasonal rivers, where during uh, the time of rainfalls, that means during the time of monsoon, when there is sufficient supply of water, then within a unit time through the river channel, a lot of water is passing, whereas in other times of the year, the channel evidences much lesser amount of much lesser volume of water passing through the channel. So thereby, when the channel water evidences higher volume of water, that time energy is much higher. When channel evidences lower volume of water, that time the energy condition must be very low. And the last one, due to which velocity of water within the channel decreases, that is due to some obstruction. If during the flow path of river water it encounters some amount of obstruction, then also the velocity, at least locally, decreased. And lastly, cessation of flow. That means if the flow path is blocked or somehow the flow becomes ceased, ends. So if the flow ceased, then also the river velocity decrease. Suppose when a river meets with a large water body, suppose when a river meets with a lake, or when a river meets with the ocean. So after meeting the oceans, there was no flow. That means the flow of the river water completely ceased, completely ends. So thereby the velocity of river water becomes decreased and ultimately diminished. So at that time also deposition can occur. Now the second part, due to excessive load, if greater amount of glaciofluvial outwash, that means greater amount of sediment compared to the water, if you look at the sediment, that means carried solid particles, and the ratio of water, that means solid particles is to water ratio, then whenever the ratio becomes higher, that means there is much amount of solid matter compared to the volume of water, then also due to this increasing sediment load, that means the entire physical property of the solvent is now changed. That means the uh, density, the viscosity of the um, fluvial water is changed. So with this changing physical property, now the water has much more tendency to drop the sediments with slight change in energy condition. So higher amount of load, higher amount of sediment within the water, it requires very low energy drop to deposit. That means it onset the deposition process compared to lower amount of load within the water. Second, increased erosion in drainage basin because of reduction of vegetation cover. If within the drainage basin it was completely barren, that means a lot of trees are cut down. So thereby there is no mechanism by which the loose particles or the soils are hold together, because we all know the root system of plants, they hold the loose particles of the soil or loose particles of the sediment. Now if trees are cut down from those areas, so they become more prone to erosion. So thereby, if the drainage basin if in the drainage basin lots of trees are cut down, so lots of weathering and erosion of those loose particles and soils happen, and they ultimately goes to the river valley, so thereby increase the amount of load. Thirdly, excessive load contribution from tributaries or human activities. So although uh, the mainstream may not have the excessive load, but the tributaries, they contribute suddenly much amount of load to the mainstream, or due to some human activity, artificially we produce much amount of sediment to the river water. So also in this process the load of the flowing water increased, and thereby onset the deposition process. So these are the process, these are the factors for which deposition from the river water will happen. Now if we look at the sediment deposition and try to track the size, as I already told you, the slope of the or the gradient of the river channel decreases from its source to mouth. So we found coarses particle at the steeper areas, coarses particle near the source or near the headwaters, and finer particles as we move away from the source. So thereby grain sizes are sorted by water, sand seals are initially removed. So near the source we mainly found gravel size particles along with some mud. Those are basically trapped within the pore spaces of gravels. Uh, if we look at the channel itself, then these large size particles are settled within the channel, and the finer size particles are moving at the bank portions of the channel, that means at the side of the channel. Sands drop out in near channel environments, that is at the side of the environments. Similarly, silt and clay size particles also. And the clay size particles can move a far distance from its source. Now, if we look at the landscape formed by the river by deposition processes, the first and foremost landscape or landform is the alluvial fan. When a river crossed is or passed its journey in the mountainous terrains in the young stage and meets a relatively flat area. That means when the river passed its young stage and enters the mature stage. At that time, when the river enters a relatively flat area in the foothill portions of mountains, then suddenly the energy of the river drops. So due to this drop of energy, fan-shaped body of coarse detrital sediments, poorly sorted, these are mainly of gravel size particles, they sudden due to the drop of velocity, they suddenly drop at the foothills of the mountains, and they form a relatively steeper slope with gradually passing to or with gradually going to some gentle slope through these foothills, and as they are distributed in a fan shape, so they are known as alluvial fan. Now initially or in the early days it was thought that these alluvial fans are formed due to uh, simply because of the changing slope or because of the changing gradient from the mountainous terrain to the flat areas. Later, it was found that it is not only the change in gradient, but because the slope or the channel gradient changes from the mountainous regions to flat areas. So now, in the flat areas, the river waters is now spread a much wider area. That means the narrow channel within the mountainous areas is now broadened much larger. So therefore, the same volume of river water is now moving through a larger bedrock. So that is why the frictional resistance force also increased along with the changing slope, changing gradient. So together these two processes, one is the change in gradient or change in slope, and the second one is much larger spreading area of the river water. So together these two cause the deposition of coarser particles in these foothill areas as fan-shaped bodies, and these are known as alluvial fans. Now, alluvial fans in humid areas shows normally low cones with a gentle slope from head to toe, and they appear as high cones with steep slopes in arid and semi-arid climates. Here you can see a diagram, a line diagram of alluvial fan, how it is occurs. So the river water comes from the mountainous portions and starts depositing in the foothill portion. The portion when the river water starts deposit, it's called its fan apex, and gradually all the coarsest particles are deposited in this portion. Now, as the deposition occur, so it may occur various times that the course of the river, that the path of the river was suddenly blocked. So with repeated erosion or with frequent changing the path of the river creates newer and newer path. So you can see these lines, these are indicating changing path at different times. So at this alluvial fan condition, river changes its flow path very frequently and ultimately distributed all the sediments in this fan shaped pattern. The distal part or the most distant part from fan apex where these fan deposits are found, that is, you may say also the boundary of these fan deposits, it's called fan toe. It is the most distal part of the alluvial fan. Now in this two figure you can see the two alluvial fans, and if you look closely you can see the spreadness difference of these two areas. Not only the difference in spreading area, but you can also have an idea about the change in slope from fan apex to fan toe in these two figures. In the first figure you can see that the fan deposits are spreading a lower area, and the change in slope from fan apex to fan toe is much higher. That means the slope is in this portion is relatively high, whereas in this case you can see that the spread of fan from this point, from the starting of deposition to the distal part, the spreading is much higher, much area is covered, and at the same time the slope from this fan apex to fan toe is relatively low. Now this change in slope in fan as well as the area covered by the fan sediments is depend on the viscosity or density of the flowing water. So depending on the carried materials, how much amount of sediment load the river will carry, that will govern or that will guide the depositional pattern in this alluvial fan region. Whenever there was a debris flow, that means the river water um, transports a lot of sediments along with its water, then we found these kinds of steeper slope, low aerial covering of fan materials type of alluvial fan. Wherever there is, when the river carries mainly the sandy, silty or pebbly materials, then the aerial spread will be much higher. So depending on the viscosity of the flowing water, the aerial spread as well as with the uh, slope of the alluvial fan will vary. So this will depict two different processes or two different scenarios and they can be identified from the rock record. Now, generally, the nature of sediments within the alluvial fans, as I already told you, they are mainly of gravel-sized particles and poorly sorted, and also they have very low roundness, low sphericity. So mostly they are angular. Now, whenever successive alluvial fans in different slopes, they clubbed with each other. Here in this picture you can see this one is one alluvial fan, and at the side this one is another alluvial fan. So if they cover a wide area and they together club with each other, they together mix with each other, so it produce a apron of alluvial fan covering the entire foothill portions. So this is called then Piedmont alluvial fan, Piedmont, Piedmont alluvial fan. Now, along with the alluvial fan, it is often seen, particularly for the ephemeral streams. That means those streams which occur mainly in the arid regions. Then, whenever they cross the relatively uphill areas and meets the flat land, they deposited these kinds of alluvial fans, and at the frontal part of this, or towards the downslope part of this alluvial fan, they found a relatively flat area, a vast flat area, as you can see in this picture, these portions. Now, often in case of ephemeral streams, as you know that the supply of water is limited, there was not continuous supply of water. So after depositing the alluvial fans, the body of the ephemeral streams, or the water of the ephemeral streams, they becomes restricted within this frontal part of alluvial fan, in this flat land area, and this is a very large area having a flat surface. So these areas are known as playa, or often playa lakes. uh, the lake is term is used because the entire amount of water of the ephemeral streams, they are restricted within these areas, within these flat areas, so the movement of the river water becomes seized. And this is not a permanent feature, because you know that the flow of ephemeral streams is very occasional, because water in the ephemeral streams is not supplied throughout the entire year. So whenever the within the ephemeral streams or within some channels, the sudden flow of water is found in the arid conditions, after crossing the mountainous portions, the water is restricted in these flat areas, and thereby they deposited all the finer particles. That means the silt, clay particles are deposited within these areas. So the sediment found in these playa lakes is mostly of very fine sized particles, and often when they are exposed to open air, that means all the water is completely dried up, often we found some mud cracks over there. Sorry. In the river course, often it was found to occur uh, a lots of uh, alternate, relatively uh, deeper and shallower part within the river channel. The deeper part are known as pools, whereas the shallower part is known as riffles. Now, here you can see in this picture, you can clearly see the pebbles, cobbles are almost exposed to the atmosphere in this portion, and you can have an idea that at this portion, river water flowing over it is very shallow. So this is called riffle, whereas these portions, in case of meandering river, the concave bank, these portions, uh, these have the maximum depth of river water, and it is known as pools. Now, in flume studies, that is one kind of experimental study done for observing the velocity change in river velocity, and thereby the change in different depositional conditions and depositional types. So in flume studies, when water is flowing in a constant rate in a experimental setup, obviously it produce pull and refill sequences in straight channel rivers also. Here you can see this is a experimental picture shown here. In straight channels also, these pools and riffles are formed. Here you can see these portions are the places of formation of pools, and these are the shallower parts, formation of riffles. And it was noted that the distance between one pool to the next, that means distance between this pool to this pool, or in other terms from one riffle to next riffle, uh, is about 5 times the channel width. So this distance from this pool to this pool, the distance is about 5 times greater than the channel width than this. And another interesting thing you may find from this feature, that here in this straight channel also, the pools are occurring alternately. So as I already told, these are the portions of deeper water, that means maximum volume of water passing through it. So maximum energy of uh, pools or maximum energy of water is going through these regions. So as you can see that of the straight channel, where there is a depression, and that is maximum volume of water is passing through these areas. So maximum energy condition within this channel is facing in these portions. So thereby these are the portions which suffers more erosions. So you can see these small vertical lines. These are the portions of the river banks which suffers erosion, and thereby the channel gradually increasing its sinuosity. That means these banks are eroded more and more, whereas the opposite bank, that is the concave bank, they are the areas where deposition occurs. So gradually the river channel migrates towards the concave bank, and deposition occurs in the convex bank. So in this way, from the straight channel, due to the formation of pool and riffles, the channel increasing its sinuosity and ultimately forms a meandering river. So this is the course of a meandering river, where you can also see that the erosion is occur mostly in the uh, concave bank, whereas deposition occur in the convex bank. Now, normally in meanders of large rivers, there is active deposition along the convex bank and undercutting along the concave bank. So if you look at the steepness or slope of the two banks, the concave bank is much steeper, almost a vertical bank wall, whereas the convex bank is the depositional bank, and here the slope is much gentle and towards the channel. So slope is in this direction towards channel. So all the layers deposited in the convex bank, they show inclination towards the channel. Now if there is no deposition and no erosion or undercutting, the tendency to meandering is reduced. So from the flume studies, it is also it can be also inferred that if there was no pools happen, or if pool happened but there was no erosion and no deposition in the pools and riffle portions or in the concave and convex banks, then stream migration or ultimately meandering formation of the river will not happen. So this is a aerial view of the meandering channel. It mostly shows asymmetrical cross profile. This part is very important. A straight channel in which the depth is mostly at the central portion, it shows symmetrical channel. You can see the depth is maximum at its center, and gradually the depth of the channel decreases towards the side, towards the banks. So this is the cross profile, across channel profile of a straight channel river. Or some these kinds of symmetrical profile is only observed in very few places of a meandering channel. But in most cases, the meandering channel shows asymmetrical profile. They show the most deeper part of the river channel along the concave side of the concave bank of the river, where maximum depth occurs, and depth gradually decreases towards the concave bank, but depth suddenly decreases. That means inclination of channel bank is very high in the concave bank. Similarly, in the next next loop of meandering river, the depth becomes opposite. That means in this portion where the sense of curvature is from anti-clockwise, is left to right, here the maximum depth occurs uh, in this side, in the left hand side of the channel. In the opposite uh, loop, if we reconstruct the channel further, in the opposite loop, when the river channel will be like this, when the sense of curvature is in clockwise direction, here the again the cross profile will be asymmetrical, but the maximum depth of the channel occurs in this portion, that means in the right hand portion. So alternatively, the depth of the channel uh, shifts its position. Now the deepest part of the channel, as you can see, it always follows the concave bank of the river. In this portion also, this is the concave bank and this one is the convex bank. So the deepest part of the channel always follows the concave bank, and deep, that is the erosional bank of the river, whereas the convex bank is the depositional bank. Now you may find a problem here, that which bank you will call concave bank and which bank you will call convex bank. If suppose you are standing at the middle portion of the channel, so here you are standing, okay, now here you are standing. Now if you look at the two banks of the river, which bank's curvature looks what to you? The name of that bank is given to that. If you look at this bank, the sense of curvature of this bank is concave to you. So this one is like a concave lens. So this bank is known as concave bank. Whereas if you look at this bank, the sense of curvature it's look like the convex lens. So this bank is known as convex bank. So concave bank is this one, convex bank is this one. Remember, for meandering river, concave bank is always the erosional bank, convex bank is always the depositional bank. Next is the point bar. As I already told you that in a meandering river, in a meandering river, convex bank are the places, are the portions where deposition occurs, and these depositions in the convex bank are known as point bars. Now, point bars are the most readily identifiable features of a meandering stream. Deposition on point bars is a major process of sedimentation in meandering river channels. The shape and size of point bars varies with the channel width as well as the flow condition. That means how much amount of water the river channel flows within it. Generally, point bars uh, are oriented across, that means transverse to the flowing direction, and the point bar sequence, the point bar deposit may be as thick as the depth of the channel. So point bar, as point bar starts from the deposition from the channel to the convex bank, so the height of the point bar or maximum height of the point bar in the convex bank is almost equals to the river channel depth. Now if we look at the depositional sediment grain size within the point bar, then you may find that coarser materials are dropped fast and finer size are dropped over it. That means with continuation of channel migration, with continuation of more and more meandering of the river, the point bar also migrating, or the point bar also shifting its position more towards the concave bank, and thereby finer materials comes over the coarser particles. So if you look at the vertical sequence of the river, you can see in this picture also. So when the channel is in this condition, erosion occur here and deposition occur here. So if you look at the grain size, suppose these are the channel lag deposits, these are the coarser particles, and grain size gradually decreases in this direction. Okay. Now, as this erosion continues in the concave bank, so ultimately after some time, the river shifts in this direction, So now this one is the channel. So my point bar will be like this. So coarser material will be deposited here, then the medium size and gradually grain size decrease. So what you can see in this portion vertically, that these fine size particles come over the coarser size particles as the channel migrates more towards the concave bank with increased amounts of erosion in the concave bank. So in point bar sequence, in point bar deposits, generally we see a fining of grain size up through the deposit. So within the point bar deposit, as we move from bottom to top, we can see grain size is gradually decreasing. We call it as a fining upward sequence. And this is the picture how point bars are gradually migrated, point bars are gradually shifted its position towards the erosional sides, towards the concave bank, as more and more erosion happens in the concave bank of the river. Apart from the point bar, there is another kind of deposition found, another kind of um, sediment deposition found within the channel, which is called longitudinal bar. This is also a type of bar, that means any kinds of sedimentation occurs within the channel. So we call them as bar. And apart from point bar, these are also one type where sediments deposition are found to occur within the channel. So these are also known as channel bars or braid bars. These braid bars or longitudinal bars are characteristics mainly of braided rivers. Generally, rivers with steep slopes and coarser bed materials, they show this braiding nature, because a river with steep slope and very high amount of debris, mainly consisting of coarser particles, with very little change in slope, very little change in velocity, they immediately drop those coarser particles within the channel, and with successive deposition, those uh, channels or those deposits, they gradually increase in size and enlarge. So these are the portions which forms restriction to the flowage of river water, and river water then gradually dissects or gradually omits those restrictions and flows at the side of those restrictions. So that forms the longitudinal bar or channel bar. But along with the previous condition that these longitudinal bars mainly formed in mainly in the mountainous portions where the slope is high and river carries mainly uh, coarser particles, gravel sized particles, these kinds of braided rivers are also observed in lower stage of the river. So along with the velocity is high, that means channel gradient is high, river can carry much coarser particles. These kinds of longitudinal bars are also observed in the mature stage or old stage of the river, where the sediment discharge, although is of fine size, but maybe is much higher in proportion. That sometimes when in the lower flow regime, that means in the mature stage or in the old stage, when river water flows a lot of discharge of sediments, if that condition suddenly happens, then also these kinds of longitudinal bars are found to occur in the lower course of the river. Now in longitudinal bar, if we look carefully, then the deposition of longitudinal bars also started with the coarser particles, and gradually the grain size decreasing up to the bar, up to the sequence. So the longitudinal bars also shows us a fining upward sequence. If we look at the morphology of longitudinal bar, the slope of this bar is gradually uh, higher, or the slope of the bar is steeper in the upstream side and very gentle in the downstream side. That means if you look at the cross profile of the longitudinal bar, it looks like this. So river water flows from this direction to this direction, so it hits the longitudinal bar in this portion, so that is why this portion is very steep, becomes very steep, and erosion occurs. And whereas this is the shadow zone, so mostly deposition occurs and this part becomes a gentle slope. So this one is the longitudinal cross profile of the longitudinal bar. Now the main deposition in these kind of uh, channel bars, or in these kind of longitudinal bars, takes place during high water stages of the river, and as long as river water flows towards downstream, these channel bars migrates towards downstream by depositing sediment in the frontal part of the bar. So as I told you, this upstream side river water directly hits, so this part is little eroded, and the eroded sediments are now deposited in the frontal part or in the downstream part of the longitudinal bar. So with time, these kinds of longitudinal bar gradually migrated or moves towards the downstream side. Next is the Oxbow Lake. These kinds of uh, features are mainly found in meandering rivers, when the meandering loop becomes extremely sinuous at this condition. As I already told you, the erosion mainly occurs in the concave side. So with time, the looping of this meander becomes extremely high, and the two portions of this loop, this portion and this together, comes very close to each other. So with time, with erosion continues at these portions, ultimately the river channel shortens its flow path and flows in this portion. They're cutting this country amount of country rock. So this is called as neck cutoff. So ultimately river abandon this channel, previous channel, and flows in a new path and thereby shorten its course. So these kinds of abundant channel, which is readily separated from the newly formed river by deposition in these mouth portions, and they form an isolated oxbow shaped uh, depositional areas with occasional supply of water during high water discharge condition. These are known as oxbow lakes, and mainly here in these lakes, as the water body now becomes stagnant, so very fine size particles, silt and clay size particles are found to be deposited in these oxbow lakes. Next is the another important feature is known as delta. Now delta formed when the river meets with the permanent water body. It may be either a large lake or it may be ocean, and at that time the flowage of river ends. Now at the confluence of river with large water bodies, these kinds of river depositional features formed, but it is to be noted that delta formed only when there is a high amount of sediment supply to that or to those large ocean basins. Without the high supply of sediment within the large uh, ocean bodies or large permanent water bodies, delta cannot be formed. So the essential condition for the formation of delta is that high supply of sediment, and thereby rate of sediment deposition in those areas exceeds the rate of removal of sediments by waves and currents. So whenever river deposits sediments in the ocean bodies, the sea waves and currents, they gradually playing with those waters and they disperse that deposited sediment in the river mouth. Now if the dispersal of sediments by sea waves and currents is much higher, then there will be no formation of delta. So there should be higher amount of sediment supply, as well as deposition rate will be much higher compared to the rate of dispersal of sediments by waves and currents. If that happened, then a typical landform occurs which looks like the Greek letter delta, and from that the name given it as delta. Deltas are extended sideways and seawide at an very fast rate. That means delta increase in their size in both sideways as well as in the frontal part. Now, like the alluvial fan, deltas also are rapid sedimentation or rapid deposition. So thereby they often blocked the course of the river path. So because of the blocking of the course of the river path by the delta deposition, river channel also shifts their path and formed new river channel. These kinds of shifting of river channel in the deltaic condition are known as avulsion. This process of avulsion in deltaic setting is known as delta switching. So thereby delta also changing its shape and size. So because of the blockage of delta sediments, river channel changes its path frequently, and this process is known as avulsion. And due to the avulsion, delta also changes its shape and size, and which is known as delta switching. Now, the shape of delta is mainly dependent on the three processes. That is, whether the shape is dominated or whether the area is dominated by fluvial processes, whether it is tide dominated, whether it is dominated, or a mixed type, that is known as hybrid. So depending on that, different kinds of delta shapes like bird foot to arcuate, different types or different shapes of delta are. The first one is the bird foot delta. Now when the river water is less dense compared to the ocean water, then it makes uh, few confined channels for itself within the river water. So when the river water is less dense, then almost it is like a floating body over the ocean water. That means the density difference between the ocean water and the river water is uh, higher. That means ocean water is much denser than the river water. So river water is almost floating over the ocean water. So in that condition, river less dense water makes very confined channels. You can see that the original river, original sea position was in this condition, and river water makes very few channels or very few confined areas within this sea waters. So thereby the river water may and deposited the sediments within those narrow confined areas. So ultimately they looks like the fingers of bird foot. That is why this type of deltas are known as bird foot delta. The famous example of bird foot like delta is the Mississippi delta. The second type of delta is known as arcuate delta. In this type, the river water density and the density of the seawater is almost same. So the river water along with its sediments spreads out like a fan. So that forms these kinds of arcuate nature of delta shape. This is known as arcuate delta. So in arcuate delta, the density of river water and seawater is almost same. So they evenly distributed in a fan shaped pattern. The last type of delta is known as cusped delta, where the density of river water is much higher than the seawater. So in this case, the river water moves within the sea as almost a bottom water current. So thereby they are creating these kinds of shallow notches, shallow depositional uh, conditions, depositional features, shallow deltas within the ocean body. This is known as cusped delta. Now the largest delta system, largest delta found in the entire world is in India. That is the delta of Ganges Brahmaputra rivers combined. They cover or they comprising approximately an area of 1 lakh 5,600 square kilometer. Now, apart from the streams which supply continuous water, we know that there are another type of streams mainly found in the arid areas, which is known as ephemeral streams, in which there is very occasional flows. So these kinds of ephemeral streams deposit mainly some poorly sorted angular to subangular clast. Often normal grading is found to occur there. So these characters are very important to identify whether the deposits are of ephemeral or perennial streams. So if someone asks you identify identify the characteristic features of ephemeral streams, so these are the criteria. They are poorly sorted, the deposition are of in nature, and they often show normal graded bedding. Now the one important thing, that is drainage evolution. In drainage evolution, one important incident happened, that is drainage reversal. So the thing is very simple, that the flow direction of river channel changes through time due to some tectonic activity. Say for example, the flow direction of rivers in South America. Now, when South American, South African landmass are together, then all the river channels are flowing from east to west, because these are the highland areas. In these are the highland areas, and all the rivers from these highland areas are flowing from east to west. But after the separation of these two land masses, of these two continental land masses, and now the entire west and east coast of South America is open to ocean body, and the Nazca plate in the western coastal part or western margin of the South American plate, here Nazca plate, that is a oceanic plate, is started submerging below the continental South American plate. So due to this submerge, due to this collisional setup of an oceanic plate, the Nazca plate, and the continental plate, the South American plate, upliftment of Andes mountain range happened. So due to this upliftment of Andes mountain range along the entire western coast of South America, now the western part of South American landmass becomes elevated. So all the rivers previously flowing from east to west, they have to change their course due to the upliftment of Andes range, because the overall slope of this South American landmass is now from west to east. So thereby rivers changing their direction and flowing in the opposite direction, that is, they flow from west to east. So previously the river flowing from east to west, when African landmass and South American landmass are together, general slope of the landmass is from east to west, all the rivers flowing from east to west. After the separation of South America from South Africa, Nazca plate is subducting below the South American plate, and this mountain range upliftment occurs. General slope of the South American landmass changes from west to east. Thereby, the drainage system of the South American landmass reverses. This process is known as drainage reversal. Another type of drainage evolution is known as antecedent drainages. It is also happened due to some kinds of tectonic activity, mainly tectonic uplift. Now, when due to some kinds of tectonic upliftment, some amount or some barrier was found in the course of the river path. Here you can see that a river is flowing in this direction and meets with the sea. Now, due to some tectonic activity, a mountain range or an upliftment occur in this portion, and that basically blocks the flow of river. So what happens if the amount of or the rate of upliftment is proportionate by the erosion by the stream or the incising of the stream, that means the rate at which this upliftment occur, at the same time river cuts through these uh, restrictions, river cut through these hillocks. If that rate is same, then river can uh, take its path through these restricted bodies and meets with the oceans. This is called antecedent drainage. That means the rate of incision, the rate of creating passage through these uplift areas is almost equals or greater than the rate of upliftment. Then river can cut these uplifted areas and meets with the permanent water body. So this time the drainage is known as antecedent drainage. But it may happen that the rate of upliftment exceeds the rate of incision. That means the rate at which river makes its path within these uplifted areas is much lower than the rate of upliftment, than that this upliftment occurs much faster. Then the river water is not able to make passage for its flowing within these uplifted areas. Thereby the river water is blocked completely by this uplifted mountain range, newly formed mountain range. So now river starts flowing parallel to this blockage. That means they starts moving in this direction or they starts moving in this direction. So these kinds of change in drainage pattern due to some kinds of tectonic upliftment, either river water makes passage when the rate of incision is almost equal to the rate of upliftment, then it is called antecedent drainage. But if the rate of upliftment exceeds rate of incision, streams are divided around the uplift and flows perpendicular to the general flow direction, or you can say flows parallel to the uplifted areas. So in summary, if you look at the three course of river can be separated in three course: the upper course or young stage, middle course or mature stage, and lower course or old stage. And depending on these three areas, the energy condition of the river also changes. In the young stage, energy is higher, whereas in the old stage, energy is much lower. But keep in mind, the river channel is always V-shaped. Sometimes it look I-shaped, always V-shaped, never it is shaped like U. The U-shaped valleys are only found in glacial valleys. So river valleys is V to I-shaped, narrow V to I-shaped in the upper course or young stage, whereas when middle course comes, the river valleys V becomes much broader, much wider, and in the lower course it becomes much wider and more wider. So always V-shaped, but with the change in velocity, with the change in gradient from upper course to lower course, the opening of V widens more and more. And along with the energy condition of the river, different features are formed. In the upper course, mainly V or I-shaped valleys or gorge, uh, interlocking spars, waterfalls are found. Mainly these are the erosional features. In the middle course, some erosional features, that is the meanders, also formed, along with some point bars or some depositional features also found, alluvial fans and longitudinal bars. Whereas in the lower course of the stream gradient and flow velocity is extremely low. Meandering is at its peak. Mainly Oxbow lakes are found. Floodplains occurs, levees found. Longitudinal bars are also found in these cases. Deltas are found when river meets with a permanent water body. So these are the characteristic features and channel pattern at different stages of river. So thank you. Hope this will make you understand about the different processes of river occurring in different stages of the year, different stages of the river, and thereby they form different landscapes. Thank you.